All right, folks. Hello and welcome back once again to the only nationally syndicated radio show all about the information economy. It's called Inside Analysis. Yours truly, Eric Kavanaugh, is here. And I'm very pleased to have Arun Varadarajan. He is the founder and chief commercial officer for a company called Ascendion. And we're going to talk about a new development paradigm. So, just to give some context for that, as anyone who has worked with professional services firms know, they typically make their money by the hour. And if you want to do something new, they're like, oh, we need more people, more money, got to jack up the price. So we'll make more money and give you new stuff. And then there's the other side of the equation, which is that a lot of times, if you want to go faster or for less money, they're like, well, it's going to cost you in terms of quality. So you have to give up something, either quality or price, money, or ideas. Like even don't even start your project because maybe you can't afford it. And I think Arun has come up with a pretty clever way to address that. And it's an end-to-end engineering platform. They figured out there are all these friction points, 150, I think is what I heard him say, friction points from idea to production. So what are those and how do you solve them? Well, we live in a very interesting world these days where you can have teams work together on projects without holding each other up. I give an example all the time about how Google blindsided Microsoft with Google Docs, allowing multiple people to work on the same document at the same time, which was an absolutely brilliant innovation. Saves tremendous amounts of time and effort. You don't have to throw things over the wall anymore. You can all be looking at the same document, typing, editing, and the technology tracks who did what. So you have all these wonderful guardrails and safeguards built into the technology, and that's what you want. And I think they have something like that for a development platform. But with that, Arun, I'll throw it over to you. Tell us a bit about Ascendion and what are these friction points?
Absolutely. So Eric, the Ascendion journey started about 4 years ago, and we had a group of us who came from the overall engineering and software industry, and we had realized that there were fundamentally three issues that clients were facing. There was a crisis of trust, there was a crisis of speed, and what I call as a crisis of capital.
Hmm.
Now, the crisis of trust was, you know what? These guys will show up at my door and say, hey, don't worry, I'll get this done for you. This will be the cost. I've got these accelerators. I've got these really good talent. I can get this work done for you. And then they show up at the door and say that. And then when the reality, what do I say, manifests, they find that, oh my God, I'm being charged more than what I was told. I don't have full transparency into how things are being done. I don't know what your engineers are doing. It's a black box. I have no clue.
Hmm.
The second is a crisis of speed. Everybody comes and says, yeah, we will accelerate you. We will drive more value to you. And then lo and behold, when you say, I want to accelerate, the first thing the service provider says is you need to add another 100 people.
Right.
That cost. And then listen, one thing I can tell you is we add more people into a software engineering project, it actually slows you down. It doesn't increase your speed because you add more humans into the software process, which is it's very nebulous, not superly defined. You'll find that there are more errors creeping in and you're busy fixing those errors, right?
Yeah.
So it's actually a negative move to add more people to projects. The third was crisis of capital. Now, what is the crisis of capital? Over the years, because of the first two issues, clients have been building software with a lot of technical problems, and we call it technical debt,
Hmm.
a lot of tech debt.
Yep.
So what happens is your capital is locked on these legacy old code, and you're spending a lot of money just maintaining it, and you don't have enough money to do new things and innovation. And I call that the crisis of capital.
Hmm.
So all this was creating, in my opinion, a log jam and a Gordian knot, as I call it. Okay.
Hmm. I love
Which
the Gordian knot.
yes, and I said, it's time to untangle this. So the thesis statement for Ascendion was, let's go back and understand what is causing this problem. And to me, I went back to the manufacturing world and I saw how lean manufacturing transformed the entire manufacturing world, right? Otherwise, earlier, if you had to do a line change or a die change or a product change, it took you days to do it. You had issues with product quality. You had a whole bunch of things. With lean manufacturing, where automation and to a large extent AI fundamentally transform manufacturing. And I said, if manufacturing can do it, why are we lagging behind? Why can't we do the same thing with software? So we went back to the drawing board and really looked at the entire engineering value chain, right from ideation through to production, through to even post-production, and said, what is causing what is causing this friction and problem? And to a large extent, I'm sorry to say that it is the humans.
Right.
If you give if you give 4 humans one requirement saying, hey, I want to do this, very simple requirement. It could be a very 2, 3 lines of description of what you want the software to do, and you give it to 4 different engineers, you will get 4 different code bases for the same requirement.
Sure.
You will also get 10 different bugs that each of them will come up with. And I said, this is ridiculous. It's time for us to change. So that's when Ascendion was started, with the notion that we are going to build a platform. The platform is fundamentally going to have the ability to support the different actors in the engineering value chain, use machine learning and AI, and try high degree of repeatability, standardization, and really get the process. See, if you look at the software process today, it is all in documents. With the platform, what we're doing is we're taking the process and instantiating it into a physical platform that will drive the process and ensure that there is standardization and scale. That is what we have been. And thanks to all the AI work that has been going on over the last 2 to 3 years, we've been able to take this to a different level, and I'm happy to talk more about it.
Yeah, well, so standard components, that's one thing you can focus on, right? Making solutions modular. Maybe walk through what are some of the foundational components in the platform and maybe explain how it is, I'm just guessing here, that developers can work on different parts of the process without causing each other trouble and without delaying each other, right? Because that's one of the huge challenges is when one group has to wait for some other group to finish something and then they get delayed. So now these guys are off the ranch, basically just twiddling their thumbs. You don't want that. You want everybody working at the same time without disrupting each other. What are some of the component parts or buckets, if you will, of development that you've isolated?
So we have gone even more radical, right? So our radical thinking is that, why do we even need humans to actually do any of this?
Hmm.
And we are thinking differently. We are actually saying that, so if you look at our industry, we do different things for our clients. So sometimes we'll come in and build a new platform for a client where we have to take it from idea to production, as you mentioned earlier. Or the client will say, listen, I have an old platform. I want you to modernize it. The old platform could be written on something like COBOL or PL1, which is 40, 50 years old language, and they want to move it to a modern construct. So there are several such asks from our clients. And my view was, why can't I get AI to do all of this? So today, if you look at our platform is what is known as an agentic AI platform.
Hmm.
So I literally have an agent that can do anything you want it to do. And I can configure this agent to say, okay, agent, read this. So a requirement in our world is called a user story, basically saying this is the story that you will present to the user, right? And this is how the user will use the software. So the user story is a very important input. Now I have an agent that will read the user story and create the code. I have an agent that will read the user story and create the testing that needs to be done on the code and execute the testing, right? So what we are doing is, and with this, what we're fundamentally doing, Eric, is now when you write a user story, if I'm a product manager, my job is to write a user story. That's my role, to write user stories. But the funny thing is, if I, again, just like I mentioned earlier about developers or engineers, if I give somebody an input to write a user story, and the input is typically called an epic. So if I give you an epic and I say, please write user stories for this epic, and if I give it to 4 different product managers, I will get the user stories written in 4 different ways and will not cover all of the needs of that epic, because the human can only think so much.
Right.
But what I'm doing with AI is I tell the AI, hey, here's the epic, generate user stories. And I have live examples where I've done this time and motion study and comparison between what the human output is and what the AI output is, right? So when I give an epic to one of my AI agents and say, generate user stories, it may generate 14, 15 user stories that cover all of the aspects of what the system needs to do in
Hmm.
the first iteration. Whereas if I give that to a human, I sometimes see them coming up with 7 or 8. They're not able to think about the edge conditions, the limit. When you think about software, you got to think about all the eventualities and all the possibilities that you may have to encounter as a user. And many times as a human mind, we have these limitations, right? That gets taken away. And then I can do this at scale instead of having, each time, let's say I have tons of epics and I need to attack all these epics. I need to add more product managers, right? Here, I just add more agents.
Hmm.
And I still need product managers because I will have them eyeball what the agent creates,
Mm-hmm.
not taking the human away from the loop. But I'm fundamentally saying, hey, if I had 10 product managers doing the job, maybe I just need 2.
Mm-hmm.
And more
Well,
importantly, these
no,
product
go.
managers are really improving the agent's ability and efficacy to do this even better.
So, if you don't mind my asking, the agents that you've designed, what language did you use to design them? How do they run? Do they run in containers? Is this a containerized environment? Tell me a bit about that.
So our platform is completely containerized.
Okay,
It
that makes
follows
sense.
all the modern methods. It's a platform. So our platform allows you to create agents. And I can create an agent for different use cases. So somebody may come to me, like one of my clients came to me the other day and said, listen, uh, I've got these Perl scripts. Now, Perl is again one of the old scripting languages that nobody uses anymore,
Right.
right? So he said, I've got Perl scripts. I really want to convert them into Java. And he said, I'm trying to get my engineers to do it. It's taking way too much time. And I've got tons of Perl scripts. I've got these 400 applications running in my data center, and I want to move them to the cloud. And I can't really use Perl scripts if I'm moving to the cloud. I want to move it to the new language, Java. In the old days, what we would have done is we would have tried to use these code converters that will take the Perl scripts and convert it into whatever language. That is not working for us anymore because we want to move to microservices and
Mm-hmm.
containerized component-based applications.
Mm-hmm.
What we are doing is we have changed the process. So I have an agent which goes and interestingly, I put 2 of my principal engineers with our platform, and we were able to get this done in weeks for our clients who actually took months to try and do this.
Hmm.
So what we did was we had what is known as a reverse engineering agent that came in and read the Perl scripts and understood. And these Perl scripts can be very messy. They can have routines. I mean, I'm not going to get I don't know how technical I can get here, but fundamentally, when you have these scripts, they call each other. There's a lot of
Mm-hmm.
linkages here and there, right? So
Sure.
we actually put an agent that went and read all of this and generated what we call as a simple Ascendion language. That's what we call it, which is just English and mnemonics that describes the Perl script's logic.
Hmm.
And then I take that, and then I get another agent to come in and convert that language. And I go and tell the client, does this logic make sense to you? Right? Forget about the Perl scripts. None of us know how to read it. But does the logic of what is getting done in the Perl script make sense to you?
Mm-hmm.
He says, yeah, this part makes sense. This one I don't even think I use.
Hmm.
This part looks good. So I'm able to also say, you know what? I don't even need to waste money converting these Perl scripts because they are no longer used.
Hmm.
So I'm now got
Wow.
a document that is super efficient that I reverse engineered. So I'm can now forward engineer it whichever way you want. So I can take this document, convert them again into what I called as user stories, which is the input, as I said, the requirement input for development. And once I create the user stories, I can have an agent that converts one user story into Java. I can have one agent that can convert it into C# or whatever else
Mm-hmm.
you want, and move
Mm-hmm.
it completely into microservices architecture. And while I'm doing that, in parallel, I have agents that can create the test scripts, and I can automate the testing too.
Hmm.
So with
That's
this, what is happening, Eric, is my teams and we are completely reimagining how work gets done,
hmm.
right? There's no
You,
need for rework now. The biggest, I'll tell you, 30% of project costs is rework because
hmm.
the developer didn't understand the user story. The user
Interesting.
story was not written correctly because the product manager did not understand the user needs and did not elaborate the scenarios well. The testers did not test the software correctly. These are all the pitfalls we are eliminating by running these agents and bringing in high degree of standardization and scale.
Hmm. That's very interesting. I understand conceptually what you're
Yeah.
talking about. Did you use Gen AI for this reverse engineering? Is that how you loaded a Perl script? You said, hey, what is this thing actually doing? Was that a Gen AI application? We got 1 minute left in this segment. Go ahead.
We use a combination of Gen AI and other AI. So we use machine learning, we use deep learning, and we use Gen AI, depending on the type of problems we are trying to solve. With Gen
Hmm.
AI, we've been able to take this to the next level.
Mm-hmm. Well, I can imagine. I mean, I remember playing around with it whenever it came out a year and a half ago or so, and immediately drawing the conclusion that if it can write in French and German and Spanish and English, that it can
Yeah,
probably write in COBOL and
yeah.
C# and C++ and Java and these other languages. And guess what? It can. My understanding, having researched this a good bit, is that it'll get you 80% of the way there typically, and then the last 20% is the mile you have to do fine tuning, manually checking things. You do want to make sure that, as you've already suggested, you have a human being monitoring things, making sure that the outputs are accurate. But the beautiful thing about software that works is that it works, and if it doesn't work, then it doesn't work, and you know very clearly in a binary fashion, is this accomplishing the task or not? And if it's a no, you have to go back to the drawing board. But it's very interesting stuff. Well, don't touch that out, folks. We'll be right back talking with Ascendion about a new way of doing software. It's a lot faster and probably a lot more efficient. We'll get into the details in our next segment. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on Inside Analysis, talking to Arun Varadarajan. He is the CCO and founder of a company called Ascendion. It's just like it sounds, Ascend with ION at the end. And they have developed a new platform for software development that is agentic. They have all sorts of AI agents out there now. This is the talk of the town in Silicon Valley and around the world, quite frankly, because if a machine can do a job better than a human, let the machine do the job. I mean, humans make mistakes, machines make mistakes too. Gen AI, we've talked about, famously makes mistakes. It generates things. So you have to do all sorts of work to train it and to ground it, basically. But that's not really what we're talking about here with this agentic stuff, though you still want to monitor what they do and guide them. And frankly, this is my big question about agentic AI is how do we monitor their behavior, correct their behavior when they're wrong? How do we orchestrate their behavior? Because you got a bunch of little guys out there doing stuff now. Do they overlap? Is it log files that get spun out of these things? How do you actually know what they've done to where you can correct them or optimize what they're doing?
Amazing, amazing question. Unbelievable question. So what we are, when we, first of all, let me explain to you what is an agent architecture.
Okay,
What is
yeah,
agent comprised of?
please.
How to build it, right? So what we have done is we can build agents for anything under the sun, right? But we decided as a company that we want to focus on building this agentic platform around one value chain, which is software engineering. Because we said we want to be super specialized in this area.
Hmm.
So if you really look at an agent has got 5 elements to it. First element is it has what is known as a prompt template.
Okay.
That's where you tell the agent what is your goal, what is your purpose, what am I expecting you to do, how should you operate, how should you write the code, how should you write the user story. I'm telling it a lot of things, right? So I've started defining the framework around which it needs to operate. The second element of the agent architecture is the model. In our platform, I can literally use any model. I can use Anthropic, I can use, Azure, OpenAI, I can use Llama from Meta. We can use different models, and we have our own viewpoints on what models work best for what type of use case. So our platform allows our customers to say, hey, I've got a relationship with AWS, so they can use AWS's Bedrock services to choose the model. But we help them with model selection. So that is the second element of the agent. The third element of the agent is what I call as its memory and its knowledge, right? That is where I feed the agent with all of the knowledge it needs. For example, when I'm writing code for a client, I may be writing a code on authentication. My client may already have an authentication framework saying that go get the entitlements from this server, go get the access rights from this IDP or whatever. I can teach all of that to the agent so that the agent does not go and generate generic stuff. I can also teach the agent on all of the technical standards, the kind of language that they use when they write something. So it has this, what we call as in-context learning, or its knowledge base. That is the third part of the agent. The fourth part of the agent is where we define guardrails, because that's very important. If you're writing, for example, an application where you're using things like social security number, etc., you want to make sure that the application does not expose the social security number, right? It still maintains the format. Social security is 343. So it'll maintain the format, but I don't want it to be exposed. Or you may have certain ethical standards. You may say, listen, when I design, I don't want to think about race. Or when I think about design, I want to be inclusive. All of those things can be put in the guardrails, and we use a guardrail framework. And the fifth is every agent can be associated with tools, because I may have an agent that needs to use a tool to get something done, right? It may have to use a testing tool, or it may have to use a web scraping tool. So this is the architecture of an agent. Now, what we do is when I am building an agent, we actually have an agent that helps me build an agent.
Nice.
And we are also starting to use genetic algorithms to really improve the efficacy of an agent for a given use case.
And what was that again? You use what?
Genetic algorithms or
Oh,
evolution.
genetic algorithms.
Yeah,
Okay.
yeah. So what we are doing with genetic algorithms is, if I have a use case and I have two, let's say, agent candidates, I input it into my GA algorithm, and it will generate children. And you know how GA, I don't know if you have, I presume you and your audience know how genetic algorithm works, but it works just like human evolution, right? It mutates, it creates multiple strains of the agents and multiple versions of the agents, multiple generations and children's and whatnot. And what we do is we have what is known as a fitment function, right? Or a fitness function that we have defined for that use case. And the fitness function will decide which of those children go to the next generation. Literally like, evolution. And we use that method to come up with a high quality agent candidate for a given use case.
Okay, I mean, so just to give some context to the listeners, what you're talking about is kind of what they have in the database world of a query optimizer, right? A query optimizer figures out how to do the job better, faster, more accurately, for example, pulling data from various systems. And you can do, there are all kinds of different machine learning algorithms out there. So you can use different means to determine how efficient is this, could it be more efficient? And what you're saying is that basically these genetic algorithms, you have a sort of a fleet of them. You use them, see which ones work better than others. The ones that work best, you continue that one, you don't continue the others.
Correct.
And thus you are incrementally improving these individual agents and the algorithms that they use. Is that right?
Correct. And this is in the beginning when I'm building an agent. right?
Okay.
So when I'm right off the bat, I have a very high propensity for being accurate in the agent's capability to do something, right?
Mm-hmm.
So right off the bat, we are starting with good quality agents through our process.
Right.
Then we also run a whole range of analytics. So every time when when the agent does something, let's say the agent writes a piece of code for a developer, and the developer looks at it and says, I like it, and clicks says like, that goes back into my platform and I'm capturing it. So we call it answer relevance. So if an engineer says, test this code for me or optimize this code for me or whatever, and if the engineer likes the output of the agent, then that goes back as analytics. And I'm constantly monitoring the analytics of these agents to improve either the prompt or give it more learning and improve its knowledge base, or
Mm-hmm.
fine tune the guardrails, or create or implement new tools. And this is a evolving process that we follow, right?
And that's largely through user provided feedback. Is that correct? Or is some of the feedback also agentic?
So very good point. What we also are doing is, because we have so literally what we're doing is we're mimicking the work world in our platform.
Mm-hmm.
So we have two types of agents. We have a manager agent and we have co-worker agents. So the manager agent is actually managing all the co-workers, and he or she, the manager, she may decide that the same piece of work I'm going to give to two agents. And I'm going to say who comes back with a better result,
Hmm.
right? So we can even have two agents doing the same piece of work and find out which is more effective and take that output too. So that
Mm-hmm.
is something that we call them workflows in our platform. So I can literally create a workflow where I can concatenate multiple agents and put a
Mm.
master agent on top and say, okay, go build this piece of software.
Hmm.
So the first agent may just take the epic, understand the epic, generate the user stories. The manager agent may say, I don't like that. I'm going to get another agent to come and do the same and see which one is better.
Mm-hmm.
And then once he or she is happy with the work that was done in terms of building the user stories, she can invoke we can use she and he interchangeably because these are, AI agents, I presume. So it can go and then kick off the next set of agents. And if it finds that the work needs more agents, our platform allows the manager agent to spawn more agents so that more agents can attack the work. So this is how the whole thing can. So we foresee at some point in time, as we improve the efficacy of solving different problems for different clients, we could potentially get to a true factory model, like you see in a process chemical plant, where the process is running and there's one guy or two people sitting in a room with a cockpit, tuning this and tuning that and tuning and looking at gauges and letting the factory run the process.
Sure. Sure. No, well, you're reminding me of these transformers, right? The whole concept of the transformer. And I actually have a thread going with Jürgen Schmidhuber to hopefully come on my show someday. And we were talking about this, and it's the same kind of thing where you have an array of agents or automatons, let's call them, and there's one that manages them and thinks through. It's like, huh? Because like if you think about how these large language models work, from what I understand, it's still next character, basically next
Yeah.
token, what is most likely based upon the prompt and my training, et cetera, which is a very linear process. But with the transformers, now you've got a sort of supervisor who can kind of look over and go, I think I'll go with you this time and you that time, which I think is very clever. And that's, I think, also reflected in Mistral, right? With this mixture of experts, that whole architecture
Yes.
is very similar, and that you have some agent that is basically orchestrating the behavior of a group of agents, and they all work as a team. Is that about right?
Exactly. Exactly. Now, the interesting thing is, now think about what I told you in the initial part on our thesis statement of why we started doing this. If my client comes to me and says, I gave you three files, three COBOL files to move to Java, I'm now going to give you 1,000 files. All I need to do is to run parallel workflows.
Yeah, right. Sure.
And
Which
I
is
don't,
what these GPUs are made for, right?
right? And I don't need to bring in more humans. I just need to have,
Right.
maybe 10, maybe 5, 10 humans who are looking at the process. So
Right.
I've told all, so if let's say let's say you're a senior software engineer. What does this mean to you? Because your role is going to change.
Mm-hmm.
What I'm telling my senior software engineers and my principal engineers is earlier you would work on writing the code for your client and optimizing the code and blah,
Right.
blah, blah,
That's
blah.
right. That's
That was
right.
what you were doing. Now, what
That's
I
right.
want you to do is to make these agents more effective in doing that for your clients.
Right.
So
Well,
you get,
I'll throw a theory at you. I think you're going to agree with this because I think a lot about AI and the impact on workflow, on day-to-day lives, on how we actually build things, in
yeah,
particular software. And as a general rule, I think we're at a massive inflection point. It's an inversion, really, because in the past we pushed the machines. Like think a lawnmower, I'm pushing it along the way using my strength and guiding it myself. Well, in the now in the near future, it's turned around where the machines are sort of pushing us, but we're still guiding them. We're still trying to shepherd them, say, no, not this, or yes, more of that. So, but the point is that the impetus is now coming from the machines. They're creating these things, and we're just sort of shepherding and guiding them almost like a gardener does in pruning a tree. What do you think?
totally. So, in fact, I'll give you a very interesting example. There is a role in the software engineering world called as a tester or a quality engineer. So his job is to test, or her job is to test something. So think about now what's going to happen to her role. So I've told her now, I want you to stop thinking yourself as a quality engineer. I want you to think yourself as a quality systems engineer. What does that mean? You are
That's
going to run
good.
the quality system.
Right.
You're not going to do the quality engineering. You're going to run the quality system. So you should know how to engineer your quality system so that you can ensure. And if you know, I still go back to manufacturing because these guys have cracked it. If you go back to manufacturing, they have this notion called total quality management, where they go to your supplier's supplier all the way through to the raw material to make sure that every part of the inbound value chain is bringing in the quality for you to build the right kind of ball bearings or whatever you're
Yeah,
building.
right. Sure.
So with this quality system, so today most of my testers are only trying to test what the developers are done. They're not
Right.
testing to a large extent what the product managers are writing. They're not
Right.
testing how the users are thinking.
Oh, interesting. No,
Right.
this is very important because what you're speaking to is the criticality of understanding the whole process end to end. And we talk a lot about this on these various shows, things like error propagation. If it gets all the way upstream, it just spreads to the entire environment. And now it's like tainted water, for example. If you get some poison in the water, if it's in the distribution system, then it's everywhere and you've got a huge problem. Well, if you stop it at the source, that's when you really make some hay. But folks, don't touch it. We'll be right back. You're listening to Inside Analysis. All right, folks, back here on a fascinating Inside Analysis episode. We're talking to Arun Varadarajan. He is the Chief Commercial Officer and founder, and they have built an agentic platform that allows their clients to leverage the power of agentic AI. What is that? They're little AI agents. They're little semi-autonomous mini applications that can do various things. And I'll throw this over to you. What I've heard from lots of companies who are doing something similar to this, like Verint, for example, has automatons. They have like I think 20 of them now, and they plan to have another 20 soon. And what their CEO told me is that they want each agent to do one thing very well. Because I had asked him, do you want the agents to learn to do multiple things? And he basically said, not really, unless you're talking about the orchestrating agent, sort of the manager agent that has the bigger picture in mind. And if all this stuff is declarative in nature, that's great, right? Because you have an end state you want the agents to achieve. The manager is watching to see how that gets done, is instructing the individual agents to do their thing. Go get this data, you process this data, you check the data, you double check the data, you push it to production. All these different agents get their instructions, right? And you can parallelize that stuff. Like for go get that data, spin up 100 agents to go pull in a big, large amount of data and then start analyzing it, acting on it, pushing it production, et cetera. That's all declarative, right? And then again, my question is, how do how does the real person manage that stuff? What kind of levers can they pull to change what's happening?
So to me, actually, I don't fully agree on that notion
Okay.
of your
That's fine.
client. I actually think while I agree with that, you need to have an agent kind of focused on an area. I wouldn't use the word task alone, a space. You want to use the generative capabilities of AI today. Because I can tell you, all we want to do is to create some boundaries and say,
Mm,
listen, thou shalt operate in this space, and let me give you all the knowledge you need to be effective in this space.
hmm
So we expect actually our agents to bring in a high degree of creativity, and I'll show it to you. I'll show it to you when I show you the platform. Because what's happening is when my manager agent tells, hey, you agent, go write the code. When she comes back with the code and says, here's my code, I'm ready for you to move to the next step. He says, no, I don't like some of this.
Mm,
Change it. You have not addressed some of these things. It goes and explores that and improves it. So
interesting.
yeah, so what we are thinking is that these agents need to use reasoning because there are decisions that need to be made. Should I write it this way versus that way? So we want the reasoning abilities, which is what agentic AI does. It really leverages the reasoning abilities, because you need that.
hmm I mean, that's what humans do best, right? I mean, right now, that's I think, our leg up on on the AI agents at the moment, is that we really can think through. You look at this story about, was it Apple's new chip? They have a new quantum chip, I think it was, that solved some problem like like a million times faster than it ever would have been solved before. And it's because you have sort of multiple layers of things, right? I mean, I've given the example in the past of Carl Sagan when I was a kid, blew my mind because he talked about two-dimensional characters in a two-dimensional world and how they can't see past each other. But if someone came along and picked one of them up into the third dimension, now they can look down and see everything. And that is huge. I mean, think about getting through a labyrinth. If you can get up in the air and look down at the labyrinth, now you can figure out exactly how to get out of there. Whereas before, it would have been a very painful trial and error type environment. And I think what you're hinting at here, or even openly articulating, is that if you have the right array of agents and the right architecture, then they can all sort of check and balance each other and much more strategically solve problems. Is that right?
Very true. We have our agents. In fact, we have the peer agents talking to each other already.
Hmm.
And the manager agent comes in and just kind of draws some boundaries and says, hey guys, let's not go crazy here.
Right.
Stay within this bound. But if I find that you're not giving me the output that I want you to go back and iterate again. Now, the thing is, as we are, so in fact, when I sit down with my team, we are not trying to solve the simple problems that, these RPA type of companies are doing.
Right.
Because robotic process automation is very deterministic in
hmm
its fashion. Go
Right.
fetch data. My agents can do that, but I'm not really, I want to solve the tougher problems. So for example, I'll go back to testing. One of the starting points in testing is I will go to the development team and say, hey guys, what are you going to be building in the next round? They call it sprints, in this agile world. By the way, agile is also going to go away with all of this. I will tell
Hmm.
you at some other point.
There you
Agile
go.
is going to die. Now what's going to happen is I'm going to go as a test manager or whatever and ask the development team, what are you going to build in the next round? Because why is that important? Because I need to now figure out what should I test? Where should I test? Right? It's
Right.
important because I may be building some things that are new. I may be changing things that are already in existence.
Right.
So I actually have an agent now where I can get your sprint plan. I can get, what are you planning to do? I can get your schedule that you have. I can get a whole bunch of things. And then the agent is able to generate saying, this is the testing you need to do.
I
That is
see.
not like going and fetching a piece of data. That
Right.
is the reasoning power.
Right.
I'm
Right.
expecting over time that things like design, architecture. So when we used to build systems, there was a lot of time we used to spend around architecture and design because there are a lot of decisions that need to be made that have implications on various aspects. It could be performance, it could be, user experience, it could be 100 things. And for the human mind to do to really do trade-offs beyond 4 or 5 dimensions is not possible.
Right.
We can't think like that. We're not, some of us are lateral thinkers, but we may miss some of these things. So
Hmm.
in those areas where you really need to think about design and really come up with what works best, I think these agents are going to do better than us.
Wow. No, I can see that because when I think about how computer systems are working now, I mean, first of all, we have just wild, crazy innovation in all directions. I mean, these deep learning modules, like you see Gemini and Claude and all these various things. I try to explain to people there is no limit to the number of permutations for how these things can be built. And they can even be dynamic and change over time and sort of
Yeah,
readjust, dynamically adjusted software defined software development is kind of what it boils down to. Right,
yeah.
and that's what you're getting at, and because whenever we talk next, I wanna get into the details of the reasoning of these things and how you score and manage the scores of all the agents in certain environments for certain tasks. Because if you are incrementally inching closer to more and more efficient design, that's very, very, very interesting. I mean, right now, if I could just make a blanket statement and I'll give you 90 seconds to comment on it. If you think about the compute that happens in any large organization, I mean, VMware came along and optimized that to a large extent, right?
Yeah.
Optimized use of CPU and things of this nature, which is important. But all in all, if you think about all the unnecessary crunching of data and processes that are not generating value, not even needed, we're probably at like 20% efficiency. I think. And so if you get this right, you could save, like, we're talking trillions of dollars at scale. We got a minute, 30 seconds. So what are your closing thoughts?
100%. Let me tell you, the first market I want to disrupt is there's a low-hanging fruit. And I know I'm going to piss off some of my peers in the industry, which I'm fine doing because that's why we're here for.
Right.
They are making oodles of money and literally, taking the clients to ransom around testing. You'll be
Oh,
amazed. These
interesting.
companies have thousands of people testing software today. And some of these companies, I mean, I don't want to name them because I'm not here to necessarily shame them, but
Right.
but they have to really reflect some of these large firms, and you know the names. I don't need to tell you. They make billions of dollars in testing, and you know how do they do the testing? They just put butts on seat,
Hmm.
butts on seat. That's all they do. And let me tell you, with this model, I think, in fact, when I started Ascendion, my notion to the team was, I think CIOs are spending, let's say CIOs are spending $100. I don't think they should spend more than $15.
Yeah. I I'm with you. I mean, I
That's what I
totally
think.
see this,
Yeah.
and we're gonna pick this conversation up at a future show, I am sure. When folks look these folks up online, Ascendion, I think is Ascendant. I'm pretty sure about that. They certainly have the right idea because you can optimize the freaking daylights out of what is being done in the world of computing these days. I'm talking absolutely massive gobsmacking savings if you do it right, and it'll be vastly more efficient. We'll talk to you next time, folks. You've been listening to Inside Analysis.